Hello and welcome back. In this video, we are going to talk about Apache Oozie and its uses. Now, all this while, we have seen how to extract data using Scoop or Flume. We have seen how to write a MapReduce job in Java, and we have executed pig scripts, and we've even loaded data into HBase and ran Hive and Impala queries as well. Now, given an application that uses Hadoop as part of its technology, you could potentially use all of these to achieve your final objective, be it just data loading or processing or both. Now, we have primarily seen how to execute all the above from the command line. However, in a production application, executing from command line on a daily basis is not a good idea, as that would mean a lot of manual work. Ideally, you would want to automate their execution. And typically, most applications would have some sort of a data flow. You would probably want to run your MapReduce job after your Scoop job has run, and then follow it up with a pig script, and then maybe run your Hive or Impala queries. This is where Oozie comes into picture. Basically, Apache Oozie is an open source project based on Java technology that simplifies the process of creating workflows and managing coordination among jobs. In principle, Oozie offers the ability to combine multiple jobs sequentially into one logical unit of work. We'll shortly see what a workflow or a coordination is. Using Oozie, Hadoop administrators are able to build complex data transformations that can combine the processing of different individual tasks. This ability allows for greater control over complex jobs and makes it easier to repeat those jobs at predetermined periods. So without much ado, let us go ahead and create an Oozie job and see how it works. I'll explain the concepts and a lot of related terminology as and when it is relevant. So first, let us take a very simple example of running a MapReduce job from Oozie. Okay, but before that, let us see how to run a MapReduce job from the command line. So here we use the Hadoop jar command for the same, right? So what we're doing here is we are providing the jar file path, the name of the class from the jar file that needs to be run, the MapReduce queue name, which is basically an optional parameter, and the input file path for my MapReduce job, and finally where should the MapReduce job write its output. Now let us see how to execute the same MapReduce job using Oozie. Remember, Oozie basically acts as a middleman between the user and Hadoop. So the user provides details of his job to Oozie, and Oozie executes it on Hadoop via a launcher job and returns the results. So the user can provide the details of his job using three different components, right? First, we have the job.properties configuration file. Then we have the workflow definition XML file, and finally the libraries required for the execution of the job. So first, before we configure the files, let us understand the workflow definition. Oozie provides mechanism for the user to set various parameters that we discussed above, such as the queue name, input directory, output directory, etc., in a workflow XML file. The workflow.xml definition is nothing but a set of actions arranged in a direct acyclic graph. Now, you need to execute the MapReduce word count program. So for this, the DAG, or the direct acyclic graph, will include control flow nodes like start, end, and the kill nodes. The start, end, and kill nodes essentially define the beginning and the end of a workflow. The start node basically indicates where the workflow has to start, and the end node indicates where the workflow will end, and the kill node indicates what should happen when there is a failure of a particular action. The control nodes also provide a mechanism to control the execution path through the use of decision, fork, and join nodes. We'll see the use of these nodes in the next couple of videos. Now, action nodes are nodes that trigger the execution of a computation or a processing task, such as a MapReduce job or a pig script. In our case, the action is the execution of a MapReduce job, and once it is successfully run, it will end the workflow, or if it fails, it will take you to the kill node, where you can create an error message to be displayed to the user and then end the workflow. So as you can see, a workflow definition is a DAG with control flow nodes or action nodes that are connected by transition arrows. So with that understanding, let us go ahead and configure the job.properties file. The parameters for Oozie job are provided either in a Java properties file or in a Hadoop configuration XML. In our example, we will use a .properties file. Here you basically specify the essential parameters needed for running the workflow as variables in this particular file, and these variables will then be accessed in the workflow XML of your Oozie job. This file, remember, it should be present locally on the node from which the job is submitted, and it need not necessarily be on HDFS. Now let us configure the job.properties for our particular example. So for the MapReduce job to run, remember, it needs to know where the name node and the job tracker processes are running. So your Oozie server could be running on a particular machine. So the Oozie server, in particular the Oozie job, needs to inform the Oozie server where the name node and your job tracker processes are running in your Hadoop cluster. So we specify this using the below variables, right? You can provide any name for the variable, but the path of the name node and the job tracker should be as specified in your XML configuration files of Hadoop, right? Next, you can specify some optional parameters for the MapReduce job. So here we specify the name of the queue in which the MapReduce job is supposed to run, and we are specifying it that it should run in the default queue. And then we configure the path of the workflow XML file. Because the workflow XML file is what contains the definition of your Oozie workflow, it is mandatory to configure this property in this particular file. Okay, and here the path that you have provided refers to the path in HDFS, and note that the name of the file has to be workflow.xml. So we'll see that in a couple of minutes. And you can also configure the input and output paths for your MapReduce job. Okay, now let us configure the workflow XML file itself, right? This is the most important part of a Oozie workflow job. So here you start with defining the name of the workflow using this line of XML code. Okay, so here word count -wf is basically name of our workflow, which we can use to identify in among all the Oozie jobs that might be currently running. Next, we need to define the start node, which is basically the entry point for a workflow job. And a workflow definition must have one start node. When a workflow is started, it automatically transitions to the node specified in the start. The node specified in the start is basically an action node. Remember, we mentioned that the action node is a node which runs a particular computation task like a MapReduce or a pig script. So in order to define an action, we use code like this, right? So you're using the action element and you provide a name to the action element. So in our example, when the workflow is started, it automatically transitions to the word count action. So note that in the start node, we are mentioning that the to element or to attribute is specified as word count, and we have an action by the name word count, so that when the workflow is started, it automatically takes you to that particular action. And since it is a MapReduce job that we are running in this workflow, we indicate that to Oozie using these tags. Now you need to provide the path of the job tracker and the name node. So this is done through the use of these tags here. Okay. Remember, the $job tracker and the $name node are the variables that we have configured in our job.properties file. So now you can relate how the job.properties and the workflow XML file are working in conjunction. Then using the prepare element, you can specify a list of operations needed to be performed before beginning the action. You can specify operations such as deleting an existing output directory using the delete element, or maybe even creating a new one using the mkdir element. So this prepare element is how optional for a MapReduce action, so we're not going to specify anything here. So now that the basic info required for the MapReduce job to run is provided, we need to configure details specific to this particular MapReduce job. So this is done using the configuration element and is used to specify the key value properties required for this MapReduce job. So for our example, we will provide the mapper class that is supposed to be used by the job, okay, using this property called as mapred.mapper.class. We'll also provide the reducer class using this property, and then the path of the input directory on each DFS where the input for the MapReduce job resides, and then the path where the job needs to store the output. Note that the input and output paths are actually specified as variables in the job.properties file. You could as well have configured the path directly here as well. So any other property that you would want to specify for your particular MapReduce job, you're going to use a property element, and then you're going to provide the value of that property using the name value elements within that file. Okay. Now we have configured our MapReduce job. Next, we have to indicate what should happen after the job has run successfully, right? So we do that using the OK element. So OK to end, that's what it's saying. So after it is successfully run, it says that it should go to the end node. We can also set it to go to another action node and perhaps run a pig script or a hive script, right? So we'll see how to do that in the next video. And if there is an error, you can tell that it should go to the kill node, and kill node is basically you can set any error message. So in our example, we have set that indicate a message from the word count action node. Okay. Finally, we can configure the end node itself, and after the end, you basically end the workflow, right? So this is how you configure and define a workflow XML file. So to summarize, we basically configured the basic control nodes, which are the start, end, and kill. Then we configured the action node, and within the action node, we configured the required parameters and the applicable properties. So you can easily make out the flow. So first, the workflow starts at the start node, and it notes that it is pointing to an action called word count in the start node. So the action is basically a MapReduce job, and it uses properties specified under MapReduce element for setting up the job. Next, it uses key value pair setup under the configuration to run the job, and if the job completes successfully, right, then go to the end node, and after this the workflow comes to an end. But if the job throws an error in between, the control will go to the kill node, and the kill node basically stores the error in a variable which can be used for debugging. So as you can see, a Oozie workflow is a collection of actions, that is MapReduce jobs or pick jobs, etc., arranged in a control dependency direct acyclic graph specifying a sequence of action execution. The language that we have used so far in specifying the workflow XML is called as HPDL, which is an XML process definition language. HPDL is a fairly compact language using a limited amount of flow control and action control nodes, right? So the control nodes define the flow of execution, while the action nodes are the computation and processing tasks themselves. Some of the workflows are invoked on demand, but the majority of times it is necessary to run them based on regular time intervals and or data availability and or external events. So the Oozie coordinator job allows the user to define workflow execution schedules based on these parameters. So you basically first create one or more workflow jobs and then create a coordinator job and include the workflows you want to run. And if you want to package multiple coordinator and workflow jobs, you can do so by creating a Oozie bundle. So bundles basically make it easier to manage the life cycle of these jobs. And lastly, in order to complete our workflow for running our MapReduce job in Oozie, we need to configure the libraries required. So you need to first create a directory in HDFS which will store your workflow XML file, and inside this directory you need to create a lib directory which will store the required jar files. So during runtime, the Oozie server picks up contents of this directory and deploys them on the actual compute node using Hadoop distributed cache. In our example, the lib directory would contain the wordcount.jar file. Okay. Now let us see whatever we have explained in action. So what I'm going to do is I'm going to run this particular Oozie workflow on our AWS Hadoop cluster. So I have already connected to the AWS cluster name node using PuTTY. Okay. First, what we'll do is we'll need to create the workflow XML file. Okay. So I've already set this up. I'm just going to show you how I have done. So as you can see, I have a mrjob.properties and then a mrworkflow.xml file. Okay, so let me show you the contents of this XML file. Okay, so as you can see, you have a start and the action node, and then the action node is basically a MapReduce job. Okay, and note that there are two important properties that you also need to specify, which is the mapred.mapper.new.api and the reducer.new.api. If you do not specify this and we're running this on our AWS cluster, you're going to get an error saying that error configuring an object. So you need to specify these two properties as well. Okay, now let me quickly show you our job.properties file. Okay, so I've specified the path of my name node. This is how it is specified in the core-site.xml. Similarly, the path of the job tracker, the input directory and the output directory, and this particular property which is mandatory, oozie.wf.application path. So this is basically path to my workflow XML. Okay, so in this particular path, Oozie looks for a file called as workflow.xml. Okay, and let me see if I have these directories already available. So let me browse HDFS and then Oozie slash MapReduce. Okay, so as you can see, I have already copied the workflow.xml, and then I have also created the lib directory and also placed the word_count.jar file. Okay, note that I have not moved the job.properties file here because it is not necessary. Now if you want to ensure that the XML file that you have configured is valid, you can use a command called as Oozie validate and then provide the path of the XML file. Okay, so you get a valid message. If you get an error, you will have to first debug that error, and only then the Oozie workflow will work for you. Okay, now the command to run a Oozie job is Oozie job, and then you need to provide the path of the Oozie server, right? So the path is basically http:// since Oozie is running on the same machine, I'm going to provide it as localhost, but if it's running on a different machine, you need to ensure that you give the proper server name here, followed by the port, which is by default 11,000, then /. So this is where my Oozie server is running, and then I also need to provide the path of the properties file that it is supposed to run. So I'm going to specify the path as mr job properties, which is basically because I'm already in that directory. Note that the job.properties file name could be anything, because you're going to explicitly specify that it has to use this particular properties file, and then -run. Okay, so this will run your job. So if you get such a message, it means that it has initiated a Oozie job with the ID like this. So the W at the end indicate that it's a workflow job. Okay, now I'm gonna launch the web console of Oozie. So these are all the jobs that are currently that have run so far, and this is the one in running status. Okay, you can see that, you can see the flow here, right? So it started, okay, and when the status is okay, it transitioned to our word count node. The word count node is basically a MapReduce action, right? And then when it is okay, it moved to the end. So you can see that this is how the flow is, and if you see the job direct acyclic graph, this is how it looks like. Okay, okay, now I can go and check the output of this MapReduce program. I had specified a directory called as wc output Oozie, so you have that directory created. So let me check the contents of this file, sorry, directory. You can see that the output has generated properly. If you want to check the status of a Oozie job on the command line, the command that you have to use for the same is Oozie job. You provide the path of the Oozie server, okay, and then specify -info, and then whatever is the ID of that particular job. So you can see that whatever you saw on the web console of Oozie server, you're pretty much seeing the same here, just that the web console provides a few more options. So you can see the job log here, you can see what is the job configuration, you can also see what is the job definition, okay, and you can see the log of the individual action, okay, and if you can actually go and see the log of your task tracker or your mapper. Any output you can go and see here. Okay, so that is the flexibility that your web console provides. You can see all the jobs that are running, that have run, and the status, that start time, the end time. Okay, and you can also change certain settings like the time zone, etc. Okay, so get used to the Oozie web console. It will give you a lot of information about your jobs. Okay, now one thing you have to note, that Oozie does not support cycles in a workflow definition. That is, a workflow definition must be a strict direct acyclic graph. You cannot have a particular action run in a loop. So you can't start with a MapReduce action, run a big action, and then go back to the previous MapReduce action. That does not work in a direct acyclic graph. Okay, so before we move on, right, let's have a brief word on the installation of Oozie, right? So Oozie can be installed on an existing Hadoop cluster, but since we already have a Cloudera Hadoop cluster on AWS, we have used that for the sake of convenience, and our Hadoop installation is Cloudera's CDH4, and it already contains Oozie. So that's the reason why I did not have to explicitly set up Oozie. There are two components in a Oozie distribution, which is basically a Oozie client and a Oozie server. And depending on the size of your cluster, you may have both components on the same edge server or on separate machines. The Oozie server contains the components for launching and controlling jobs, while the client contains the components for a person to be able to launch Oozie jobs and communicate with the Oozie server. Now, helping Hadoop users in chaining and automating the execution of big data processing tasks into a defined workflow is an extremely useful feature in real-world practices. However, Oozie is not the only project that can help you achieve this goal. There are other projects like Azkaban, which was written and open sourced by LinkedIn. You have Luigi, which is basically a Python-based workflow engine, and you also have Cascading, which supports any JVM-based language such as Java, JRuby, and Clojure. So with that, we come to the end of this video. We have seen how to execute a MapReduce job using Oozie, and we've also understand a little bit more about Oozie actions and how to set up a workflow XML file. Thank you for watching and stay tuned.